Alright guys, so this is going to be a very quick video explaining the difference between continuous graphs and discrete graphs. Okay, here's what you need to know. Continuous graphs are basically any type of graph that can be drawn with one line, okay, without picking up your pen or pencil. So on the bottom here, or underneath this word continuous, we have 6 examples of continuous graphs. Each of these graphs can be drawn without picking up my pen or pencil the entire time. Okay, I start at the way left and I can draw it without having to pick up my pencil. Okay, that's what it means to be continuous. It can be drawn with one smooth line, one smooth stroke of your pen. Okay, but the opposite of continuous would be discrete. And when you think of the word discrete, I just want you to think like individual points. Okay, so these are 4 examples of discrete graphs. And basically what they look like is a bunch of different dots or a bunch of different points. I have to pick up my pen every single time I'm drawing these graphs. If I'm picking up my pen at least once as I have to draw the graph, it's an example of discrete. So it's pretty simple. Discrete means points, continuous means connected. So we'll do a quick example or 2 of these. Here I'm asking if the word problem scenario is discrete or continuous. Okay, and I keep writing it down. Discrete means points, continuous means connected. So it says, at an ice sculpting competition, each sculptor's height was measured to make sure that it was within the regulated height range of 0 feet to 6 feet. And then the judges' results were as follows. Team 1, 4 feet, Team 2, 4.5 feet, Team 3, 3.2 feet, and then Team 4, 5.1 feet. Okay, so a little bit different, but the way this is written is you could basically look at each of these entries as like points on a graph. Okay, so the first point you see is Team 1 had a height of 4 feet. You could plot 1, 4. Team 2 had a height of 4.5 feet. You could plot the point 2, 4.5, 3, 3.2, and then 4, 5.1. Okay, those are basically 4 different points, and there's nothing connecting these points from one to the next. Okay, so if you were to graph this, it would just basically look like 4 different dots on a graph. So if you have 4 different dots with the things not connected, this is an example of a discrete situation. Individual points. Okay, and then the next one, it says the speed of your car as you travel from Munster to Chicago. So if you ever looked at your speedometer as you've driven or your parents have driven, it's always going to be like one smooth motion going from one speed to the next. Okay, you usually start in the park position, which is 0 miles per hour, and then when you get out of your subdivision or wherever you live, out of your neighborhood, your speed goes up slowly. Okay, you go from 0 miles an hour slowly to 20 to 25 to 35. Then you might hit a stoplight, you might go back down to 0, but you don't jump immediately to 0, you kind of ease into it. And then once you get on the highway, your speed goes way up, and then as you get closer to your destination, it goes back down. If there's traffic, you might go back up and back down. But your speed smoothly transitions from one thing to the next. Okay, you don't jump immediately from 60 to 0 when you're talking about speed. Okay, it transitions slowly from one thing to the next. So because I can connect my speeds with one smooth line, this is an example of a continuous situation. Okay, this would not be individual points. This would be one smooth line can connect my speed the entire time.